Hi guys, welcome to Unit 6. This is for Astronomy 120 or Astronomy 1001, the new version of Astronomy. So this covers Unit 6. The topic is on basically the year, and it really deals with the motion of the sun. You will see what I'm talking about in here, or at least the apparent motion of the sun. So we know that the Earth is the one that is going around the sun, so it's not the other way around. Anyway, so we will talk about the annual motion of the sun relative to the stars, because it appears to change position. And then we recall the dates and names when the sun reached extreme points, okay, in its journey around the Earth. Obviously, I'm saying that this is an apparent motion, not a real motion, okay? So you have to really understand that the Earth is the one that goes around the sun. It's like you're sitting in a car that is moving at 50 miles per hour, and you look around and you see the trees moving in the opposite direction. Everything else around the road, like houses and signs and things like that, moving in the opposite direction. Of course, you don't think that the trees are moving. I think you should know that you're the one who's moving in that forward direction. So that's in a similar analogy. And then we will define the ecliptic and the zodiac and relate them to the Earth's orbit and explain how the solar heating, basically the difference between summer and winter is, and what causes it, and how that depends on the latitude, basically on our position on Earth. And then describe the precession and that how it affects our view of the sky. Obviously, the Earth is tilted, the axis of the Earth is tilted, but that tilt is not fixed in space. It actually spins around. And that's a long cycle. Right now, the tilt of the Earth is pointing toward the Polaris, but a few thousand years ago or a few thousand years from now, it will not be pointing toward Polaris. So that's another thing that we're going to be talking about. So, the Earth, as it goes around the sun, gives the impression that the sun goes around the Earth. At least that's the apparent motion. And where the position of the sun. So if this is, for example, on June 21st, you look at this orbit and you will see the Earth is here, the sun is here, but it appears as if it's in the Taurus constellation. Okay. So the Taurus constellation is one of the signs of the zodiac because those are basically 12 constellations that go around the Earth. Basically, the position of there are some asterisms that define these constellations, where the sun seems to be located in this constellation, and because of the yearly motion, this position changes. For example, on August 1st, the sun appears to be in the Cancer. And so on and so forth, Leo, Virgo, depending on the time of the year as you move around. Okay, so those are the different constellations, the signs of the zodiac, basically the thing that is part of astrology, and how they are related to the motion of the apparent motion of the sun around the Earth. Okay, the ecliptic, basically the plane where the sun moves around in the year. You know that again, the sun is not going around the Earth on the ecliptic. It's actually the Earth. The sun is stationary, and the Earth is the one that is moving on the ecliptic. So the ecliptic plane is the plane where the sun seems to be moving around the Earth. Okay, that one, and the celestial equator. Remember, the one that is a projection of this equator from the Earth. The equator of the Earth, the projected to the sky, it becomes a celestial equator. It makes an angle of 23.5 degrees. That's because the Earth is actually tilted by 23.5 degrees, its axis of rotation, compared to the ecliptic itself. Okay, so that's really where that is coming from. As the Earth goes around the sun, let's say we're starting from December, we move to March, June, September, and we complete the full cycle back to December. Okay, the tilt is always pointing toward Polaris in all of these times. Okay, and you will notice that in December, the northern hemisphere is pointing away from the sun. Okay, pointing in the opposite direction, whether in June it's pointing toward the sun. And it's the opposite for the southern hemisphere. The southern hemisphere in June, it's pointing away from the sun, and in December it's pointing towards the sun. So that's really the biggest clue into the seasons. So is it because, I mean, what affects the weather on the earth? Is it the distance? We know that on December 21st, the earth is actually the closest from the sun. Had it been the distance, if the distance is really the main thing that drives the weather, we should really be hot in December and cold in June, but that's not the case. So the distance has nothing to do with it. Okay. The overall distance, the average distance between the Earth and the Sun is about 150 million kilometers. It's around 147 million kilometers in December and 153 million kilometers in June. So if the distance is the main thing, and that's why this is a myth, this is not a true reason why the seasons have to do with anything with distance. The other thing we know is the fact that if it's winter in the northern hemisphere, it's summer in the southern hemisphere. So if that's going to be the effect of the weather, it should affect both northern and southern hemisphere. So that is not true. The other argument that you may have is that, listen, the earth is tilted away from the sun. Therefore, the northern hemisphere, at least in December, would be further away from the sun than the southern hemisphere. That's true. And if you look at it in June, there is summer in the northern hemisphere and winter in the southern hemisphere. So you might think, okay, we are pointing away, toward the sun in the northern hemisphere, therefore it's hotter, and then away from the sun, therefore it's colder. There is an effect, but it's really a small effect. It says in here, it's a minute fraction of the extra heating. So it's not really the main thing. What is causing the weather, though, is when you are tilting toward the sun in June 21st for the northern hemisphere, or in December 21st in the southern hemisphere, you're getting exposed more toward the sun. The rays come straight down on the hemisphere instead of getting into an angle in here, instead of getting through a long distance before reaching the ground. That's one thing. The other effect is the day is longer. So there is more buildup of that heat. The earth is gaining more and more of that heat, okay? Sorry about the noise outside. The neighbor is doing some stuff with his backyard. I don't know what it is. Anyway, so the point being in here, it's the tilt causing the radiation to come straight down. That's one thing from the sun. The other thing, the day is longer. There is more and more chance for the sun to build up more heat during the day, and that's why the summers are warm in here in June, and that's why the winters are hot in the southern hemisphere in December. Okay, so again, the key dates in here to remember, again, this is the Earth going around the sun on the ecliptic plane. That's not the only object that goes around on the ecliptic plane. All the planets, basically, more or less, okay? And all of the objects in the solar system, with the exception of the ones that are far away or small objects, okay? So again, on June 21st, this is the summer solstice. On September 22nd, it's the fall equinox. On December 21st, it's the winter solstice, and on March 20th, we have the spring equinox. That's when the day and the night are equal to one another. During those times, the sun crosses from June, being above the equator, hitting more the northern hemisphere, and in December, below the equator, hitting more the southern hemisphere. Okay, so that's basically how this works. Okay, equinoxes is when again these 2 points where the sun's path on the ecliptic crosses with the equator. That means if you happen to be on the equator on that day, the sun is going to be immediately above your head, right? On either March 20th or September 22nd. So that's when it makes the cross between the seasons. So you have a very good explanation of the seasons. Now, if you happen to be in the northern hemisphere, I'm sorry. No, this is in general. That's not the point. So we have the equator in here. The sun is immediately above your head. If you happen to live on 23.5 degrees somewhere in northern Mexico or somewhere in Africa or extending all the way through Egypt, and there is a very important city in southern Egypt called, now they call it Aswan, in the old days they call it Sian, where this fact played a major role in determining the size of the Earth, and we'll come down to it down the road in some units, okay? On that day, the Earth, on June 21st, the sun would be immediately above your head, on your zenith, okay? On the opposite of that, on December 21st, the sun will be below the celestial equator, and if you happen to be at negative 23.5 degrees, again, on that day, the sun is going to be immediately on your zenith. This is how the sun rises and sets on a yearly basis. If this is the compass pointing toward the north from the south, on December 21st, the sun rises far to the south and sets far to the south. Obviously, this is a sunset. Okay, so the sun is setting toward the south. On June 21st is further north. It's still the south for us in the northern hemisphere, so that you know. We are at 34 degrees, so we are well above the 23.5 degrees. So it's still to the north from us, and it rises further, to the south from us, but it rises further to the north than when it does whether in December 21st. So it's further north. It stays far longer in the sky, crossing the entire sky to set in the, again, more north than what it would do had it been in the December 21st. So December 21st rises very little and then sets very quickly. In the summer, it rises very far to the north from where it was on December 21st and sets in the same location west. And the summer solstice, in the equinoxes, whether in March or September, is smack in the middle between these two. Okay. These are 3 vantage points. Here you are at the North Pole. On June 21st, the sun rises but never sets. So you have an all day, 24 hours, okay? Basically rises slightly higher and then sets and slightly lower and stays in the sky, really, okay? So there is a kind of variation in the lighting, but not to the point where it goes completely dark. And it's the opposite in the winter. Okay. If you happen to be in the equator, again, the position of the sun is below the equator or southern of the equator, and it's further north in the summer and further south in the to the south in the winter. And if you happen to be way in South America, for example, the sun is most of the time is in the northern skies, and it again dips up and down. Okay, I hope that this point is clear now, and of course this does not prevent you from doing the reading on Unit 6. The precession, as I mentioned before, the axis of the Earth is tilted, but it's not staying in its position. This cycle takes a long time, about 26,000 years. It changes. Okay. So right now, today, it's pointing toward Polaris. And it changes, okay? It changes, it moves around. Down the road, before in the past, at least it was pointing toward a star called Thuban, about 6,000 years ago. And Thuban actually, it's coming from the Arabic word which means a snake. This is where Thuban is, okay? And then, so 6,000 BCE plus 2,000, that's 6,000 years, okay? That's really the math behind it. And if you wait about 12,000 years from today, it's the northern, it's not going to really be pointing toward Vega, but it's going to be very close from it. So Vega is going to basically be a circumpolar star at that point, but very close from where the North Star, where the true north is. So again, Polaris will not be at that point in the northern sky. So again, all of this has to do with the motion of the Earth around the Sun, and the fact that it's tilted, and this tilt is actually also spinning, taking about 26,000 years to complete a full cycle. Thank you.